Hi everyone, Dan Muller here. I work here as a creative strategist in Facebook's Creative Shop, and I maintain a specialization in AR. And I'm really excited today to take you through some examples of simple effects that we could make that we can take some tips and some tricks from to add to either your selfie effect or to your world effect that you're building as a part of the hackathon. Now, we'll go through some simpler things, we'll go through some more advanced things, and hopefully there's going to be something for everyone to take away from this. So sit tight and we'll explore. And yeah, hopefully there's going to be something really cool for you to add. I'll make some call outs along the way to how we can use the things that we're building to integrate them with either plane tracking or with segmentation or target tracking to enhance and to extend the work that you're building. So let's dive straight on in. If we go across to Spark, here I am, classic quick tips style. And the first thing we're going to do is take a look at building a particle effect. So some of you may have been with Spark for a while, some of you may be much newer to it. So we'll look at particles and we'll play around with some settings to work out how we can get them looking interesting. The reason why we're going to do this is because for selfie effects in particular, and you can use particles in a world effect of course too, but for selfie effects, it's really important to make sure your effects are visually engaging, visually interesting, so that people have a reason to share them, that they're going to want to put them on the platform. And particles are a simple way to add some visual interest to your effect. So let's dive on in. I'm going to go over to my assets panel and import from my computer 4 images here. So I have 4 separate pictures of different sport balls, and I'm going to select all of them and bring them into the asset panel. Now, of course, we want to be creating an effect for this hackathon that's going to communicate something that the user is really passionate about. So, you know, people are often quite passionate about sport, so why not start here? But of course, these images could be absolutely anything. So we'll dive straight in to now creating a particle system. So I'll go to the Add Objects menu, we'll scroll to the bottom, and choose the particle system, which you can now see shows up emitting from a single point right in the middle of screen with no textures assigned to these rectangles at all. They just have a checkerboard texture on them. So I'm going to select the particle emitter and we'll move it down to just below the frustum of the camera. So we can see, of course, the rectangle for the camera. If we have it below that, then we don't see where they're actually being emitted from. We just see them coming up from the bottom of the screen. Now, it's really important when you're creating an effect that you keep mindful of the aspect ratio of the user's device. Different people have different screens, and if we're laying something out to fit exactly around that screen frame, we may need to pay attention to how it might change and get our effect to update dynamically as well. You can do that using the camera properties in the patch editor, but that's for another time. Suffice it to say, just be mindful of how you're laying things out. So from here, we have a current point emitter coming up from the bottom of frame, and this might be cool for maybe smoke or fire or something like that. But we want to use these particles to make it look like balls are bouncing around the screen. So I'm going to change my emitter type from point to line, and you can see now the particles are all being emitted from a line across the bottom. These are different values along the x-axis that they're being emitted from. Of course, the x-axis being the red one. If we rotate to the side, you can see there is no variation. The line is simply going back and forth along that x-axis. I could rotate it if I want, but these default settings are cool for what I'm looking for. So I'm going to now change the length of this line from 0.1 to 0.4. So we can see now this line is emitting particles from outside the edges of the screen as well. So we're now getting particles filling up the entire screen from the bottom. Again, we could change these into bubbles, we could change them into sparkles, we could do whatever we wanted really. And if they were, for example, sparkles or little fireflies, or maybe we're like camping, we're really passionate about that, we could use our particles in that way. But to make them continue going all the way up the screen, at the moment you can see our lifespan is set to 0.4, and they're dropping out very quickly at the bottom of the screen. So I'm going to change my lifespan to 2 seconds, which means they're now going all the way up the screen. So we can begin to modify these properties to get these particles to behave in exactly the way we want them to. And so from here, we're getting a bit bored of looking at this checkerboard texture. So let's add the actual ball material. So I'll go down to my materials for the particles. They currently have nothing assigned. So I need to hit the plus button just here. And a new material 0 is created. We, of course, see that over in the asset panel as well now. And if I go to the material properties, I can now go to under diffuse texture, the drop down, and choose ball 0. To assign to the particles. So now we see this soccer ball or this football, depending on which country you're watching from, floating up the screen. But you'll notice that it's looking a little bit gray. If I look at the original texture in the property inspector here, you can see the white is very white, whereas on screen here in the particles, it's looking a little bit grayish. It's a bit muted. Now, the reason for that, if we go back to the material, so I can select the emitter, properties inspector, double click the material, or I can just select that material 0 straight from the asset panel. You can see the shader type is set to standard. So when it's set to standard, we also get properties for things like specular, how shiny it is, normal, calculating an offset to the surface direction that it's facing. And these together get combined with things like our lighting in the scene to calculate how these particles should be rendered. But I want to say, no, don't worry about the lighting. Just put that texture straight on it and make it look like that image. We just want to use it straight up like a sprite, in which case I go to my shader type and I can change the drop down here to shader type flat. And you can see now things like the specular and the normals have disappeared from this shader type. It doesn't account for those. All it's going to do is render that texture straight to screen. So now what we can do is begin modifying even further to make these particles currently shaded like footballs actually bounce and move around like footballs. So let's go back to the emitter panel and we'll now start to look at things like acceleration. So obviously the balls had just been floating straight up in space, which isn't a natural behavior for a football or a soccer ball. So we want to start to add a force, in this case acceleration. And if we put in a negative value of acceleration on that y-axis, it's going to start to act like gravity. So I'm going to change this to negative 0.3, and we can see now all of those balls start dropping back down. If I now tinker around with the speed setting, which is how fast they're being emitted out of that line, and balancing that against the strength of the deceleration, I can play around and get a look that I'm feeling a bit more happy with. So here we go. We need to keep sympathetic to the user always with selfie effects. We don't want it to be too goofy. So I don't want these balls necessarily going so high in frame that they're completely covering up my face, unless that's the intent of the effect. People like it if they can see their own face clearly in an effect. It makes it more shareable. But this is where we can see how we maybe can combine this with segmentation, right? If I have these particles in my scene, I could perhaps have particles floating up from behind me with my body segmented in front of it. So it looks like those balls are behind. I could then have maybe a lower layer of balls in front with a second particle system. So in this way, we can keep playing around with all those different combinations of all these variables we're playing with. So I'm going to turn the speed down a bit. Let's have a look at 0.3. I still feel it's going up a little bit too high. So we'll go back to 0.25, and this is cool. Let's have a look at some of the other settings that we can play with. Spray angle is the direction that the particles are coming out of the emitter from. And you can see at the moment, they're mostly just heading straight up, but there's a little bit of tilt to them. Some of them are bouncing a little bit to the left, some a little bit to the right. And this is coming from the variation attribute here. So we have spray angle for axes X, Y, and Z, and variation on that normal direction that's set, that vector for X, Y, and Z. So if I set the variation of 10 degrees down to 0 on the Z axis, we can see now all the balls are just going straight up and down. If I go to the vector for Z and put it on 30, you can see that now all heading 30 degrees over to one side, negative 30, 30 degrees over to the other side. And if I put it back on 0 and just increase that variation to something like 30, we now get them bouncing around in much more interesting ways. If we now pivot to the side here, you can see that variation is only happening on that Z axis, because that's the only one that I've set right now. So we could play around with variation on something like the X axis as well to make them go somewhat forward and somewhat back, and make it look like they're coming either closer to the camera or further away from the camera as they're flying around, which gives it, again, a bit more detail, a bit more visual interest, makes it a bit more dynamic. And from here, we can play with things like the scale. So I'm going to turn the scale up to 0.15, make them a bit bigger, give them a bit more presence in frame. And I can add some variation to them as well, maybe 20%, so we have different sized balls bouncing around. And there we go. The last thing that we want to do to really bring the movement of these particles to life is looking at the spin. So at the moment, the spin is completely on 0, and you can see none of these balls are rotating around at all. So just as before, we have the default value, the set point in spin, same as we did for the spray angle for all of the particles together. And we then have a random variation that we want to add. I'm going to put 500 degrees per second of potential random variation to the spin. And so now you can see all the balls are spinning in different directions. Some are going counterclockwise, some are going clockwise, and at all different variations of speed in between. And so we now have a much more lively, much more exciting effect that someone could perhaps use to communicate their passion for football. But what we find is that if you can make your effect personalizable, if you can give the effect something that the user can customize, then they're going to feel a bit more connected to it. They're going to feel a bit more confident using it to say something about themselves because they can tailor it a bit more specifically to them and their particular needs. So just say we've made this effect, someone wants to use it, but they don't like football, they like some other game like basketball. Well, we can add a picker, so we can let people choose between those different textures that they have assigned. So try and keep in mind as you're building out your selfie effect, if that's the route you want to go down for the hackathon, think about ways that you can make it somewhat personalizable. And definitely the native UI is a great place to start. So let's go up to the project properties, project edit properties. And under capabilities, we first need to add the native UI capability. So I'm just going to type in native, and we get native UI control and insert. So this is now available to us to be used as a capability within the effect. And you'll see there's a toast that's popped up at the bottom of the screen saying our project contains a capability that's not being used. That's because I haven't actually added any of the patches or controls yet, which is fine. I'm going to say, Spark, that's cool. I'm getting to it. I'm going to add it. But keep in mind, if you have added capabilities to your project that you don't end up using, it can be a good idea to remove them from the effect. It makes your effect a little bit more performant, a little bit lighter, so it's going to distribute just that little bit further on the platform if that capability doesn't need to be there. So now that we've added the native UI capability, I can go into the patch editor. I've got my new favorite feature, which is undocking the simulator, which is great. And I can now drag my patch editor up to give us a slightly larger workspace here. So the first thing we want to do is just right-click and type in picker. So we have two options. We have the picker UI. Actually, if I type in UI, we get the picker UI and we get the slider UI. So a slider UI is going to give us a little slider at the side of screen we can use to control something. So maybe you're thinking about segmentation. Maybe you've seen effects using segmentation where we add a border to the edge of someone based on two different segmentation textures with different widths. You could use the slider, for example, to dial through rainbow colors and make that outline change, or maybe expand and contract the width of that border. There are all kinds of different creative options about how we can put these things together. But we're interested in the picker UI today. So I'm going to add the picker UI. This picker UI, once we've set it up, it's going to add buttons to the bottom of the screen here so we can choose different options. So the first thing I'm going to do is drag my ball in here. So ball 01 texture, so I can connect it to the picker UI. Now, when we do, let's show you how things can go wrong sometimes in Spark. Maybe we'll experience a crash during one of these sessions live. If so, we'll recover quite quickly. But things do go wrong in Spark sometimes, but they can be easy to debug. So when I connect this output port for the ball to the picker UI, Spark's going to throw an error and the video is going to freeze. So let's have a look at that. There we go. So the error has happened. You can see my video is no longer running, and we have a message here, invalid texture. Only uncompressed textures are supported by native UI picker. So please disable compression for them. I'm going to say, OK, cool. I'll disconnect this, which will restart the video again. And this just means that for all of these textures that I want to use in the picker UI, I can't have compression turned on. So if I select all of them at once, on the compression settings over in the property inspector, I can change iOS from automatic to none, Android to none, and older Android to none. So now we're going to have no compression for these textures besides what's actually baked into the textures, because they're all PNGs, and you can see they're all still quite small for iOS devices, Android devices, or older Android devices. Now what we can do is select this texture. I can connect it to the Picker UI. It's not going to break this time. And if I check the box here for visible, we now get the little button for the football showing up at the bottom of the screen here. If I go to ball 2, I can drag this one in as well, connect that one, and you can see now we've got the second ball, a pool ball this time, showing up in the picker. Ball 3, and connect it, and ball 4. Let's drag this one in and connect this one. So we now have all 4 options for those different sports, all at the bottom of the screen. If I click on them though, nothing much is happening just yet. If I select the Picker UI and click on the selected option index, this is the number of the slot that I've selected. So you can see the football is at index 0, index 1, 2, and 3. So I could use these values to drive, for example, a selection of a different color, or maybe a selection of a different LUT over the top, or maybe a distortion on the face, or maybe a different 3D model that's attached to my head or something like that. But the second slot is just the selected texture. So it's just saying pass that selected texture through, which is amazing because that's exactly what we need. So if I go to the material now, material 0, if you remember from the start, I assigned the ball texture to the drop-down for the diffuse color of the flat material. I can now, instead of using the drop-down, map into the consumer patch for that texture slot something from the patch editor. So if I click the input arrow here for texture, we now get a diffuse texture consumer patch into which I can connect the selected texture from the Picker UI. And just like that, we've now made a really simple effect where I can choose footballs or pool balls or tennis balls or basketballs to help communicate my passion for any of these sports with a bit of visual interest that should work nicely for a selfie style effect. So you could take these this particle emitter. You've seen how I've just been playing around with these different properties and noodling back and forward to get the balls to move exactly how I want them to. We can continue to modify this endlessly. I could parent it to a face tracker. I could make it so the balls are a point emitter instead again and spraying out of my mouth. I could make it so when I tap and hold the screen, it sprays and it doesn't, or maybe when my mouth's open, that's when it sprays out. There are loads and loads of different options. It's just a matter of diving on in and playing and seeing how you can connect them together in the patch editor, or of course via scripting, if that's the route you want to take. So that's our selfie example. We're going to move into a world example. So I'm going to switch over to a different Spark here. And let's just bring up my webcam again. So with this one, we're going to add a 3D object to the world, which is always an interesting way to kind of grab a bit of attention. If we're looking at a target tracker or a plane tracker, people want to share things that they've discovered. Or, you know, if it looks cool, if it looks a bit unexpected, then maybe that's going to be something that they're going to be more likely to share. So let's bring in the object that I've made. If we go to my computer, I've built this one for us today. So I'm importing it as an FBX, and I'll drag it into my scene here. It's a little UFO, which is sitting on top of my head. I'm just going to pull it over here so we can zoom in on it. Now, if you don't have any 3D modeling skills, that's totally fine. Just keep in mind you always have the AR library available to you with both primitive shapes from Spark AR or loads and loads of 3D models from Sketchfab that you can use to build up your effects. But it's always a good idea when you bring a 3D model into Spark to first just play around with the materials and the properties of that object to make sure they're as polished as they can be. We find people tend to like to share content a bit more that has a degree of polish to it, that looks well made. If it looks a little bit janky, people might be a little bit less likely to share it. And what we find, of course, all 3D packages are different. All 3D packages are going to interpret materials slightly differently. So just getting into those materials and those textures and having a bit of control over them to make them look exactly how you want is always going to be a good idea. So let's go into the asset panel here. And you can see I've got the 3D object. I have a few different materials here for the glass dome on the top, the base, the details, and the legs, and 2 different textures. So the textures are driving the color of the details here and the base. So let's modify these to give them a bit more polish, make them look a bit more plausible as well, a bit more physically real, so that when I do put this into the world, it's a bit more convincing, a bit more compelling, and people are maybe a bit more likely to share it as a result. And so I'll go into the shader type here. As before, we saw the shader type standard on the particles, but we've got a more advanced one than this, which is the physically based shader. So I'm going to change this shader type on the purple glass to physically based. You can see now it's changed the look of it a little bit, but our physically based shaders at the moment in the scene is just rendering the, reading the ambient light and the directional light here to calculate the shininess and the illumination on that surface. But our physically based materials work much better if you use an environment texture. And we've got loads of them available for you in the Spark AR library. So for the physically based shader, we want to turn on environment calculation. And then under the texture here, I don't have any environment textures currently imported into my scene, so it's going to give me the option to import directly from the AR library. So I'm going into the library here, and under just down the bottom here, we have an option for balcony. I like this one. I want to think about whereabouts people are going to be using this particular effect. Are they going to want to use it indoors or outdoors? And I want to try and find an environment light that's going to reflect that probable environment that they're going to be in. So I'm going to import this one. Which scene are we in? Are we in this one? Did I get it? No. Imported it into the wrong one. So I've got 2 copies of Spark open, and it gives us that option in the inspector to import it. What about this time? Yes, I got it in the right one. Cool. So we can see the balcony texture is showing up under the assets panel here. And you can see now in the glass on top of the UFO, we've got the skyline of the environment. We've got some trees. We've got some clouds showing up. And so it's immediately looking a bit more believable, a bit more plausible, more interesting, and just cooler all in all. So people are more likely to feel like it looks great when it's sitting in the world there. I'm going to turn up my metallic settings here just to make the glass look way more metallic, way more kind of alien and spacey. And I'm now going to take a similar approach to the remaining materials here. So I'm going to go into my details material, switch this to physically based, turn on environment calculations, and select that balcony texture. I'll turn up metallic. Now this texture's gone a little bit washed out after converting it to the physically based. And you're going to see this happens, this particular artifact a little more pronounced on the green base here. So if I select this base material for the green base and change it to physically based, when I do, you'll notice it goes a bit grayish. So you can see here it's gone a little bit washed out. It's a little more boring. It doesn't have that kind of cartoony pizzazz that it had just before. We're going to fix that in just a second. So I'll show you why that's happening. Next step, we'll turn on environment calculation. We'll assign that balcony texture as well. I'll turn up metallic so it looks really cool. And we'll make it a bit rougher as well to give it a bit of a satiny sheen this time. And then the legs material, last of all, we'll change over to physically based. We'll turn up the metallic, bit of roughness, and add the environment texture. So let's have a look at this grayness problem. Of course, I can see some questions coming through in the chat as well. So if you do have any questions along the way, please, by all means, add them, post them, we'll pick them up, and I'll answer as many as I can in a question and answer session once we're done with this demo. I'm looking forward to getting to it for you. So the problem here with the grayness is if we select the texture, you can see we have an option here for color encoding. So when we switch from a standard shader to a physically based shader, we're using a different color pipeline that's a bit more accurate than the default pipeline we're using for our run-of-the-mill computer graphics. And Spark has no way of knowing which color encoding, which particular approach to the color pipeline I've been attempting to use with my textures. It doesn't know that, so I need to tell Spark explicitly. So while we're in the standard shaders, usually a default JPEG or whatever should render with the same colors you expect it to. When we switch to physically based, we need to change the color encoding. So it's assuming these 2 textures, texture 0 for the details and texture 1 for the base, are encoded in a linear color space, which they're not. They're just a regular sRGB. So I need to change them back to sRGB. And you can see now the blue details just got a bit richer looking again. And with our green texture for the base, when I change this to sRGB, you'll see lots of that color comes back, and it looks much more interesting. Which is great. So at this point in time, you can see we've upgraded and enhanced the look of this UFO beyond how it looked when I just imported it. So now it's time to start putting it into the world and really bedding it in. So the first thing I'm going to do is I'm going to add an object, and we'll put in a plane tracker. So when I put this plane tracker in, we'll switch from the front camera to the back camera with this quick little animation. And we now get a little heads up here saying we can use our mouse or hotkeys to move around using the WASD. And we'll just make sure we're on simulate orbit as well, so we can simulate panning this camera around. Now I'm going to grab my little UFO here, and we'll zero out its location. So it's back here in the middle of frame. I haven't moved it from where it originally was anymore. And the last step that we want to do is we don't want to see the selfie video anymore, because I'm meant to be building a world effect. And to help us build world effects, we have this really great 3D environment here as a simulator video. It's actually sort of like a tiny little game engine of its own. So you can see now we're looking through that camera into this simulated 3D world, so we can better set up our world effects. But you'll notice as I'm panning around, the UFO is not in the world. The UFO is attached to the camera. So you might have seen this from the presentation yesterday, I believe, that our plane tracker needs to have the objects we want tracked to the world parented underneath it. At the moment, the UFO is in the hierarchy for the device. So if we imagine the scene panel as an empty void, an empty world, the plane tracker is used to understand that world and work out where the floor is. And the device is separate from that, moving around in space. So we don't want the UFO parented to the device. We want it parented to the plane tracker. So when I do that, we can now see it sitting on the floor over here. And if we zoom in, you can see it's actually sitting nice and clean over the top of the plane tracker glyph. So this square with the cross in the middle, that tells us where 000 is for the plane tracker. And we now have our UFO sitting nicely and neatly on top of it. We can now use our look around controls here, as well as our WASD keys to move around, maybe get a better, more interesting angle, get a feel for how this object is working in space. Of course, if you've played with the Spark VR player, the augmented VR player for Oculus, it's a lot of fun seeing your AR effects actually showing up in a VR world space around you. Definitely recommend checking it out if you have access to an Oculus. But now we want to dig in a little bit further and make our world effect a little bit more plausible, so it becomes a bit more convincing. People are perhaps more likely to share it. If I select my UFO, first thing we want to do is make it look a little more like this UFO actually belongs in the world. You can see the lighting that we've added to it by putting that PBR environment shader on it with the environment texture. It now looks like it's actually reflecting the sky. It looks like it's actually reflecting the buildings around it, which is cool. Just keep in mind this is going to be baked into the model. So if someone's using this effect at night, it's still going to be reflecting a daytime sky in it. So we need to think about the use cases. How is someone going to be using this effect? What different situations might they be in? And how can I account for that now? So we have the lighting on the UFO looking cool, but it doesn't have any connection to the ground right now. So with the UFO selected, I can go to the actions panel just here, and we have an option for add simple shadow. Now, I know real-time ray tracing is a really hot topic in the gaming world right now. Spark, unfortunately, does not yet have real-time ray tracing. We are still working on depth map shadows as well. So in lieu of that, before they arrive, we have loads of different hacks that you can employ to render a shadow in Spark. And this is one of them. It's a really simple setup, ultimately based on an SDF shape that's being controlled by some properties being grabbed from the UFO. And you can see we've added a nice soft shadow just underneath the UFO here. And if I pan around, you'll see as I lift the UFO up and down, the shadow is expanding out and it's going softer and becoming lighter. So it makes it feel like it's a bit more responsive to the environment. If we drag it around and move it around, you can see that shadow kind of moving with it, which is really, really great to see. and helps the UFO look a little bit more like it actually belongs in the scene. So maybe it's a bit more startling, it's a bit more delightful, we're adding some polish, we're paying attention to these details, which is going to lead to a higher quality, more convincing world effect. So if I let my UFO hover a little bit over the ground here, you'll see when I created the fast simple shadow, Spark popped open the patch editor and created these simple patches for me. So we have the UFO object itself, which is the same as just dragging the UFO into the patch editor as an object patch that we can then read for logic. That's being passed into a bounding box. So we're putting an invisible bounding box around the object, passing that into a min position and max position. It's going into a block here that was automatically created for us, a shadow for the UFO. And those values are being used to generate that SDF shadow that's sitting on the floor there. Which is cool, very fast, very easy, but it can cause some problems if we try to do something more complicated. So it will break in a little bit, and I'll show you how to fix it. So the next step we want to do to make our effect look a bit more interesting, a bit more exciting, is I'm going to select the UFO, and again, under the Actions panel, we have Animate and Float. So I'm going to automatically add some float animation to the UFO. So now you can see it hovering up and down over the floor, nice and cute. And just as before, Spark has automatically created just this really simple patch editor chain of patches for us to control that float animation. So we have a loop animation generating a progress signal between 0 and 1 based on this duration value here. That's being passed into this transition patch where we have a minimum height and a maximum height for Y. And those values are being passed into the UFO 3D position patch to make it move up and down. Now we can add a bit more detail to this again by selecting the UFO. We'll go to the Actions panel and Animate, and this time we're going to add a spin. Now the spin's going to cause two things to go a little bit wonky, and we're going to fix them. So when I add this spin, first of all, it's spinning way too fast. Like the spin rate doesn't seem super sympathetic to the floating rate. Animation-wise, it seems a little bit out of whack. And you'll also notice the shadow at the bottom is pulsing in and out really quickly, which doesn't seem to make sense. This is an artifact of the bounding box setup that's being used for the fast simple shadow, and I'll show you how we can fix that. So one thing at a time. The first thing we'll do is we'll go to the animation setup for the spinning, where we have ultimately two patches connecting into the 3D rotation of the UFO, being triggered ultimately by a loop animation patch with its duration set to 1. So this is telling Spark to make the UFO spin between 0 and 359 degrees once every second, because that's the duration that we have here in the loop animation patch. So if I slow this down to maybe a duration of 4, it's now going to take 4 seconds to rotate completely in 360. So for those of you who haven't used the patch editor all that much just yet, maybe you're still quite new to Spark, these actions can be a really easy way to understand the logic of how simple kind of patch setups happen. And from there, we can simply right-click and start to add whatever we want from the patch library here and connect them all up and wire them all up to make increasingly complicated effects. So let's now deal with that second problem, which is the shadow pulsing in and out. So this is happening ultimately because we have the bounding box being grabbed from the UFO here. And there's a bit of a calculation error. It's actually doing exactly what we've ultimately told it to inside the block, but it's not playing nicely with the rotation. So as this when the UFO is sitting there, the bounding box is an invisible square in space, and we're measuring the distance from one side of the UFO to another, and we're setting that as the width of the shadow in the block. As the UFO is rotating, that bounding box calculation is expanding and contracting in and out because of the inner bounding box of the UFO and the way it's all being calculated. Suffice to say, it's the rotation of the UFO that's causing that shadow to go a bit wacky. We could maybe dive into the shadow block, we could open that up, we could play with the maths, and we could try and fix the problem there. But it's going to be a little bit easier to use a quick hack that I've prepared for you, which is just creating a proxy object and using that to generate the shadow instead. So I'm going to go into Add Object here. We'll select a plane and insert that into the scene. You can see it's now parented to the camera. So we want to move that into the plane tracker. It's now sitting in the world here. I'm just going to rotate it by negative 90 degrees on X, which gets it to lay flat on the floor. And then I'm going to grab my scale manipulator and dragging from the very middle where the little yellow cube is. If I hover over the yellow cube and drag it up, it's going to scale out uniformly on all axes at the same time. And I want to make it about the same size as the UFO. So now that I've done that, the next couple of steps are super simple. We want to make sure the UFO is moving, or sorry, the plane is moving with the UFO, that it's tracking to it. So as it goes up, the shadow gets a bit lighter. As it goes down, the shadow gets a bit darker. And this is really, really easy to do. So if I go to my plane object here, we have the input patch that I can generate for the position of the plane. So by clicking this one, I now bring it up in the patch editor here. And you can see the transition patch is currently piping its values into the UFO 3D position. Let's just pipe those same values into the plane. So now the plane is moving up and down in lockstep with that UFO, but it's not rotating because it doesn't also have the rotation value connected to it, which is great. And now you can see we're passing the UFO object into the bounding box in order to generate that shadow. So what we can do instead is just grab that plane and bring that into the patch editor. I can now connect the plane object to the bounding box instead. And you can see that shadow is now no longer pulsing. It's looking nice and stable. Now, because we're not actually ray tracing here, we don't actually have that plane object in the scene. We don't actually have lights shining on it to cast that shadow. It doesn't actually need to be visible in order to generate that shadow. All we need is the data about where it is in the world, and then that generates the shadow in turn. So this means with the plane, I can turn that plane off. So now it's invisible, but its data is still driving the generation of that shadow. So from here, we've got all the basics of a simple world setup. We've paid attention to some detailing, paid attention to some craft to make sure it looks as polished as possible. Because as before, we know that polished content becomes a bit more shareable. People want that high quality content in their feed. So giving them something that they can easily share and that they'll want to share can be a great way to go. Now, keep in mind, of course, that I've shown you a real manual setup for a world tracking effect. Please don't forget that we do have the templates, new from template, things like our 3D stickers, and object in world, so world object and so on, that these come with really handy UI for repositioning and rescaling those objects in the world. So don't be afraid to explore those templates and really pull them apart, see what you can get out of them. But in any case, hopefully throughout this session, you've seen some bits and pieces that are sparking your interest, sparking your curiosity. We had a look at particles, how we can use those to add some visual interest. Maybe we could add some particles to this UFO to give it some trails coming out of it, or some sparks or something like that, to just keep leveling it up, keep combining those things, adding them together. But we had a look with the selfie effect with the particles, as well as at UI, and either using the native slider or the native picker to make the effect customizable so people can use it how they want to in order to communicate something they're passionate about. And in this example, we had a look at, of course, plane tracking, adding simple shadows to make it look like it belongs in the world, playing with the lighting to make it look like it belongs in the world, and changing those material types and things like our color space to make it look as polished and as convincing as possible. So with that, we're done. We're going to hand over to question and answer. So if you do have any Q&A, any questions that you wanted answered, I can certainly take them. And I've seen one just coming through now. So that's, will there be any update to use imported 3D objects as particles? Which is an excellent question, and it's something that I myself am always asking the development team. As yet, we don't have that capability released, but you may have seen inside the particle properties. There are some different 3D options that you can choose. So when I set up my example, I had it set up using planes for the particle type. There are also spheres and cones and a few other shapes in there. So for the spheres, for example, I could have just imported a ball texture straight onto those spheres, and it would have actually given those spheres a 3D shape. So they could have been looking way cooler, but it might have been a little bit more work, a little bit slower, and a bit more complicated for this particular session. But if you are interested in exploring those 3D objects, you'll find that the 3D primitives inside the Spark AR library for the simple sphere and those simple cone shapes and so on, I believe are the same objects that show up inside those 3D objects for the particles. So if you do want to UV them and texture them in your own custom way, you can certainly use them to that end. In terms of can we import our own totally custom 3D objects, not just yet, but fingers crossed. With all of these things, always the more compelling the value proposition is, and I think custom 3D objects for particles is pretty cool, the more likely it is to be released sooner rather than later. So I think that's it for our Q&A. Hopefully we've gotten something out of this. And as always, please enjoy the hackathon, have fun with it, get stuck in, and enjoy the process. Spark is a really fun package to prototype with and to play with. And I cannot wait to see what you all create. Thank you so much for your time.